Welcome back everyone, it's Mihai and we're diving into the third episode of our monthly tech wrap-up. Thanks for joining me today as we're diving into the world of LLMs. It's a topic that is of interest to me lately as I started experimenting more and more with some advanced AI applications, and hopefully it will be interesting for you as well. If you're new around here, we're covering a wide range of topics, everything that can impact your tech career from coding to open source software, self-hosting and so on. So subscribe for more content on these topics. Before we get started with this month's episode, we are getting extremely close to 1.5k subscribers, so hit that subscribe button. The first article for today is from the official Golang blog and it's called Building LLM Powered Applications in Go. Even though this title focuses on Go, I encourage you to read this article as it explains topics that apply to LLM apps built in any programming language. But why Go? We usually associate LLMs with Python. Well, Python indeed has a strong foothold in the AI world, however, when it comes to building applications around LLMs, Go has some unique advantages. LLM applications are often accessed via API calls, and Go is just better at this task than Python, and so is JavaScript for that matter. The most popular framework to build LLM application is LangChain, and we're in luck because LangChain has both a JavaScript and a Python version. However, what you might see is missing from here is Golang, so that's where LangChainGO comes in. It's a popular framework that you can use to build powerful AI applications now in Golang as well. The LangChain framework offers a few methods of enhancing LLM applications. I will highlight a couple of them. One is retrieval and the second one is agents. Retrieval focuses on connecting LLMs to external data sources to provide context and enhance their knowledge base. This is particularly useful for tasks like retrieval-augmented generations or RAG, where the LLM needs to access relevant information to answer questions or generate text. So going back to the Go article, it gives a great explanation about how RAG works. Imagine you have a large collection of documents and you want to ask questions based on their content. An RAG server can handle this in two steps. First, it takes your documents and calculates their vector embeddings. Think of them as numerical representations of their meaning and stores them efficiently in a vector database. And secondly, when you ask a question or send a prompt, the RAG server calculates its embedding, then searches the database for documents with similar embeddings and uses those as context for the LLM to formulate an answer. LangChain agents, on the other hand, go beyond simply retrieving information. They can interact with their environment and take actions to achieve specific goals. Imagine an AI agent that can not only answer your question but also book appointments or manage your schedule or even write code based on your instruction. And this leads us nicely into the second article of the month, which is called RAG is more than just vector search. This one is from the TimescaleDB blog and it ties perfectly with one of the specific topics I'm currently interested in, combining LLMs, SQL and RAG techniques. Let's take a look at the problem statement here. For example, answering the question, what were the top 5 most discussed GitHub issues from last month related to performance optimizations? Now, this requires more than just similarity search. For example, it requires time-based filtering, last month, text search, performance optimization, and aggregation and filters to give you the top 5. Embedding search alone won't cut it for a good RAG system. And that's true, RAG application can help answer questions based on a wiki, for example, but can't reason or make calculations. This is where Text-to-SQL comes in. Text-to-SQL is like having an SQL translator embedded directly into your RAG application. It lets users ask questions in natural language like they would with a human expert and then translates those questions into the structured SQL queries needed to extract the right information from the database. This can be achieved by using LangChain's SQL database toolkit. This involves having a model generate an SQL query and executing it. Of course, this poses some security risks, so be very careful when using this technique. With this technique, we want to give the LLM as much information as possible about our database structure, table relationships, and so on. One thing that stands out is the work being done to bring LLMs closer to the database itself. Projects like PostgreSQL, which I talked about in the past, pgvector, and most recently pgAI from Timescale are making it possible to create embeddings and even do LLM reasoning right within Postgres. So check out my older video on PostgreSML to see how you can do this sort of stuff directly in your database. The next article of the month is about LangChainGO dev's migration to a Postgres-based task orchestrator. This again is something we talked about in the previous episodes when we discussed RiverQ, the Golang and Postgres-based job queue system. I said then that Postgres is the obvious choice for building such systems. Let's see the reasoning for LangChainGO's migration. And they mention here that they want minimal dependencies to reuse their existing technologies like Postgres, Redis, Elasticsearch as much as possible, and flexibility and control over how schedules run. And yeah, if your stack already uses Postgres and you already have the knowledge and processes in place to effectively run and manage Postgres, then why add yet another technology and complexity to your stack? This makes even more sense when you consider that a rudimentary queue built on Postgres would rival most off-the-shelf solutions for performance. So they evaluated three options. One is using an off-the-shelf solution on top of Postgres. They mention Hatchet here. They also consider a library such as pgboss for Node.js that can help you easily build a queue on top of Postgres, or actually building it themselves. And like I said in the previous episode, doing so is very easy because Postgres has native syntax to lock and select jobs that aren't locked by other transactions. Specifically, I'm talking about the for update skip locked syntax. And yeah, their conclusion was that they were impressed that PostgreSQL handles everything they need: relational data, non-relational data, queuing and scheduling millions of tasks per month. This is just awesome to see. Now let's move on to some project and technology spotlight. And first it's Postgres itself, because version 17 just launched with new features which makes it even better. For example, they improved how the database handled memory and storage, making things like sorting and searching through large amount of data even faster. And I personally can't wait to test out the new better ways to work with JSON data, such as the new JSON table command, but also other new functions that improve querying JSON documents. Next, we have a few notable version 5 releases. So first off, Fastify version 5 is out now. I use Fastify in place of Express whenever I have the chance. I love its simplicity and its performance, obviously. Also, Astro version 5 beta is out and is bringing some major changes. One of the coolest things is the new content layer, which gives you a really organized way to manage all of the content on your website. It introduces something called content loader, which can offer a streamlined way to grab content from different sources, such as multiple CMSs or even markdown file store on a file system. And they also added something called server islands, which can help you load the parts that are interactive only when they are needed. Next, we're looking at deck.gl, which is a data visualization framework that can use the GPU for high precision computation. It can render highly complex and interactive visualization, and I was blown away when I saw some of these demos. So I will show them to you. For example, this flight map, and an even cooler one was this. And there's not much to say about this one. I mean, the smoothness and performance here is just incredible. I already have some ideas about how to use something like this. And the last project we're looking at is pgstream, a tool that can notify you about both data and schema changes to a Postgres database, so you can trigger webhooks whenever something changes, opening up a whole new world of automations you can build. So yeah, this one is definitely worth checking out. Let's wrap up with a look at some recent developments in the tech industry. One trend that caught my eye is the unexpected surge in software engineering recruitment. And I can say from personal experience that my LinkedIn has been blowing up lately. Summer usually sees a slowdown in hiring, so the uptick now is quite interesting. It seems that startups are leading the charge, aggressively reaching out to experienced engineers, even those comfortably settled in big corporations. And a lot of this surge surge, I suspect, is fueled by the new AI projects and initiatives, because everyone has been contacting me to build something with AI. So remember all those folks who said AI would take our jobs? Well, it looks like the opposite is happening. AI is actually creating more jobs and more opportunities for software engineers. The demand for AI talent is definitely something to keep an eye on if you're in the tech job market. And that wraps up another episode. I hope you found these insights valuable and discover some new tools and ideas to explore. Don't forget to like and subscribe. Like I said, we're very close to 1.5k subs. Until next time.